Greetings and salutations, good people. This video is on additional problems on finding the derivative using logarithmic properties. This comes from the OpenStax book of calculus and in terms of the Newton Alta web-based homework. So if you recall in class, we talked about the derivative of a natural log is just 1 over x. That's once we take the derivative. But now, if you have to think about it, the product, we had different properties of logarithms, right? So the first one is the product property, which it says the natural log of A times B will equal to the natural log of A plus the natural log of B. Meaning if we had the natural log of 2x, we can naturally say that this will be the natural log of 2 plus the natural log of x, okay? Now, the power property is very similar to something that you have seen before, where if you have the natural log of a to the b power, you would bring the power to the front and still multiply by the natural log of a. Meaning if I had the natural log of x squared, we would look at this as 2 natural log of x, right? Now, if I actually went one extra step on both of these, right, and I actually had to, let's say, take the derivative of this, right, the one extra step that I can tell you really quickly, right, is the derivative of the natural log of 2, which just give us 0, right, plus the natural log of x. Well, the derivative of natural log of x would just be plus 1 over x. And the same thing for here is if I had this as a function, right, and I wanted to go one extra step and take its derivative, right? So, of course, you would use its product power property, right? And you have 2 natural log of x. Well, that would be 2 times 1 over x, because what's the derivative of natural log of x? It is 1 over x. So my answer would be 2 over x. All right. The last property is the quotient property that you'll have to use during your homework is the quotient property. So it says if you have the natural log of a divided by b, we would separate it as the natural log of a minus the natural log of b. The way I remember is addition is multiplication and subtraction is division. You can interchange these properties both ways, right? But let's give you an example. So let's just say f of x equals to, let's see, the natural log of, of 4 over x, right? So this means this will be seen as the natural log of 4 plus the, not plus, minus the natural log of x, right? So the natural log of 4 would give us 0 minus 1 over x. So our answer would be a negative 1 over x, right? But again, this video isn't necessarily doing those simplistic problems, but it's doing some of the more complicated problems where we need to use our additional properties. So let's jump right on into it. Let's hypothetically say that we have f of x equals to the natural log of 7x times the square root of 7x plus 4. Now, looking at it and noticing what I said as I wrote the problem, I said 7x times the square root of 7x plus 4. So that means that 7 times x times the square root of x means that these are all going to use that product property. So we can rewrite this as the natural log of 7 plus the natural log of x plus the natural log of 7x plus 4. All right. So now that, 7x plus 4 to the 1/2, because we were looking at a square root, right? And anything with the square root, right? The square root of x means it's x to the 1/2. Now will be the time where I have one more property that I can do. This 1/2 is actually the power property. So I can really look at it as the natural log of 7 plus the natural log of x plus 1/2 natural log of 7x plus 4. Now, if I am looking at this, I am now ready to take my derivative so that I can look at each part individually. So the derivative of natural log of 7 would just be 0, because remember the derivative of a constant is 0, plus the natural log of x, well, the natural log of x would just be 1 over x, plus we can look at this as 1/2, right? Now, we discussed this in class where if we have the natural log of f of x, we would take the derivative on the inside first. So that would be times the derivative of the inside is going to be a 7, and we're going to divide that by 7x plus 4. Okay? So if I look at this, this simplifies to be 1 over x plus 7 over, if I can distribute this, right? 2 times 7 is going to give me 14, and 2 times 4 is going to give me an 8, right? But I am not officially done because I need to combine my two fractions together. Sorry, tongue-tied. So my least common denominator between x and 14x plus 8 would be both of those. So that means I need to multiply this left-hand side by 14x plus 8, okay? And I need to multiply this right-hand side by x, because again, I'm saying my LCD is x times 14x plus 8, okay? The first one is missing the 14x plus 8, and the second one is missing the x. So once I multiply that, that'll give me 14x plus 8, right? Plus 7 times x would just give me 7x all over, what was my LCD? X times 14x plus 8. All right. So we have one more step to do, which would be to combine our like terms, which will give us 21x plus 8 divided by our 14x times 14x plus 8. Now we can write it as that, or we can write it as the 21x plus 8 and distribute the x, meaning this could be 14x squared plus 8x. And then we are done. We have finally found our derivative of our function. Okay? So that's another example of using those properties in order to solve for your logarithms. Now let's do one or two more, since the video is already at 8 minutes. So let's look at, let's do this one. F of x equals to the natural log, all right, of parentheses x minus 4 squared divided by negative x minus 3 squared. All right. So this is using that quotient property where we said the natural log of a over b will be the natural log of a minus the natural log of b. So we are going to separate our fraction here. So this should look like the natural log of x, the natural log of x minus 4 squared minus the natural log of negative x minus 3 squared. Then we might notice that we have a power property as well, where again, it's the natural log of a to the b would be b times the natural log of a. So this means that this 2 is going to come to the front of here. So this will be 2 natural log of x minus 4. And then this will be negative 2 natural log of negative x minus 3. Okay? Now we get to take the derivative finally. So if I am looking at the derivative, I am looking at what's in this parentheses here. So what is the derivative of x minus 4? Well, you would tell me just 1, right? But 1 is also going to be multiplied by this 2 hanging on the outside of here. All right? And we're going to divide it by, what is our f of x? X minus 4. All right? Minus, what is the derivative of negative x minus 3? Well, you would tell me it would be negative 1. But we also need to multiply it by this 2 hanging on the outside, which would then give us 2 times negative 1 over negative x minus 3. Okay? Now, I can simply rewrite this as 2 over x minus 4 plus, because I'm going to go ahead and multiply these two together, plus 2 over negative x minus 3. So we need to combine our like terms. So we would look at, okay, what would be my LCD for this? So my LCD would be x minus 4 and negative x minus 3. So that means on my first fraction, on my first term, I am missing the negative x minus 3. And on my second fraction or term, I am missing the x minus 4. I need to distribute my 2's, so that will give me a negative 2x minus 6. And then this will give me a positive 2x minus 8. All right? And that's all over that LCD. So the next thing is to combine our like terms. Well, the 2x's would cancel, and then I would be left with a negative 14 divided by, what's our LCD? X minus 4 and a negative x minus 3. And then that would be your answer. Okay? I think I have time for one more where I can get you started at least. All right? And then I'll leave it to you to work out the rest. All right? So let's look at one more. And here we go. So we have f of x equals to the natural log of the cube root of 3x plus 8 divided by 4x plus 4. All right? So we have a lot going on. We have the cube root of 3x plus 8 divided by 4x plus 4. So that means that we need to use our properties, our logarithmic properties, to simplify it first. So this cube root, remember, means that this is saying the natural log of 3x plus 8 divided by 4x plus 4 to the 1/3. Because remember, just like the square root of x equals to x to the 1/2, right? That also means the cube root of x is equal to x to the 1/3. Now we need to do one more thing before we get to doing the derivative, is we'll bring this into the front, which means this will be 1/3 natural log, but we are dividing these two terms, so I would look at it as 1/3 times the natural log of 3x plus 8, okay, minus the natural log of 4x minus 4. Okay? Now, if we look very carefully, we can do each term first, and then we can look and come back and multiply everything by 1/3 once we clean up what's inside of the parentheses. So first things first, let's take the derivative. So the derivative of that over there, of this right here. So derivative of 3x plus 8 would just give us a what? A 3 over 3x plus 8. All right? Minus the derivative of the 4x minus 4 would just be 4 over 4x minus 4. Okay? Now, in order for us to combine our two terms in the middle here, we would need to find the LCD. So the LCD between 3x plus 8 and 4x minus 4 is both of those terms put together. Okay, so I want to multiply the first one times the 4x minus 4. So that is 3 times 4x minus 4. And then this is minus 4 times, you want to multiply this one by the 3x plus 8. So that's negative 4 times 3x plus 8. We distribute, and so this will give us a 12x minus 12. And then this will give us a negative 12x minus 4 times 8 is 32. So a negative 32. Then we can combine our like terms. Now, all of this is in the numerator, right? This is in the numerator. So 12x and 12x is going to cancel out. And then that'll leave us with, oh, Miss Parker, that's supposed to be a plus. So that's supposed to be a plus. So this is supposed to be a plus. This is supposed to be a plus. So now 12 minus 32 will give us a negative 20. All right. This is negative 20 over 3x plus 8 times 4x plus 4. Ms. Parker didn't pay attention to what she was writing down. All right. So we have one more little piece that we need to do because we still need to multiply it by the 1/3 that was on the outside. So since we need to multiply by 3 that was on the outside, that means we need to distribute what is here on the inside. So we are going to distribute, or rather FOIL. So 3 times 4x squared, 3 times 4 will give me 12x squared, right? Then 3 times 4, or 3x times 4 will give us a 12x, right? So this would be 12x squared plus 12x, and plus a 32x, then plus a 32. This is all for my denominator. So this will give us 12x squared, right? 12x squared plus 44x plus 32. Okay? Now, looking at this, this would be if we can look at this, is there anything that we can factor out of 12x squared plus 44x plus 32? I would say a 4. So I would look at this as a negative 20 over 4 times, I'm factoring out a 4 because I want to reduce it all the way. So 4 comes out of that. That will be a 3x squared plus 11x plus 8. And we're still going to have to multiply by 1/3. Now, the only reason why I'm doing this extra step is because most homeworks in Newton Alta wants you to reduce it all the way. So we need to take the 4 and divide it into 20, and that'll give us a negative 5, right? So this is negative 5 over 3x squared plus 11x plus 8 times this by 1/3. All right, so it went here, then we're going to go down here. Now, last but not least, is we multiply by this 3. So 3 times 3x squared is going to give us a 9x squared. So this is negative 5 divided by 9x squared times, not times, plus a 33x plus a 24. So that will be my final derivative from taking the derivative of the natural log of the cube root of 3x plus 8 divided by 4x plus 4. All right, we have one more video, which will be on the chain rule.